In this video, I want to talk to you about working in different bases and converting from different bases to base 10, and then also converting from base 10 to other bases. So if we're talking about base conversions, our first item that we'll look at is converting a number from a given base, whatever base they give you, to base 10. And then we'll also look at how you convert a number from base 10 back to another base. Okay, so you need to be sure that you keep straight which way you're going, what they've given you, and where you're headed. Okay, so let's look at some examples. First off, we're going to start with writing a number from another base to base 10. Okay, so if we're working with a different base and going to base 10, these really aren't that difficult. These are the easier of the two ways. All you're going to do is expand in the base that they give you. Okay, so if you expand 4, 2, 1, 3, base 5, we have in base 5, 3 has a positional value of 5 to the 0, 1 has a positional value of 5 to the first, 2 has a positional value of 5 squared, and 4 has a positional value of 5 cubed. So expanding this out just like you did at the very beginning of chapter 3, you would have 4 times 5 cubed plus, okay, so be sure that you notice you're multiplying the digit by its positional value, and then you're adding on the next multiplication. So 2 times 5 squared plus 1 times 5 to the first plus 3 times 5 to the 0. Now, for those of you using a TI-83 or TI-84, I want to walk you through how you would plug this in your calculator. So let's take a look at it real quick. In your calculator, let me pull mine up so you can see it. If I'm going to plug this in, I'm going to have 4 times, and to get the exponent of 3 on the 5, you use this caret top symbol right above the division, so 5 to the third. Now, if your calculator has the newer operating system, it will just show you that it raised it to the third power. If yours is a little bit older, it'll show you a little caret top symbol, that little rooftop symbol, and then a 3 afterwards. So then plus 2 times 5 squared plus 1 times 5. And I could have put 5 to the first if I wanted to. It's the same thing. I probably should have. Plus 3 times 5 to the 0. Now just remember that anything raised to the 0 power is 1. So that's really just plus 3. Hit enter and your answer should be 558. Oh. So in this case, it's 558. Okay, so let me pull that back up for you, for those of you who need to see how that was entered in. Okay, let's work on our second one, 2E8 base 12. Now in base 12, you have digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But because a digit can only have one position, they use an E for the 11 and a T for the 10. So if I was to expand this out, this one's going to be 2 times 12. Now again, working from right to left, this is going to put me 12 to the second, plus E is 11 times 12 to the first, plus 8 times 12 to the 0. Okay, so let's see what we get here when we multiply these out. So I have 2 times 12 squared plus 11 times 12. Again, not necessary to raise it to the first power because it's still 12. Plus 8. You can either just add 8, or if you want to add 12 to the 0 power, remember anything to the 0 power is still 1, so it's still the same thing. So 428 is our answer in that case. Now, when you're converting from another base to base 10, it's not necessary to write the base 10. If you wanted to write 10 down here as a subscript, you could, but you don't have to. So if there's not a base written, it's understood to be base 10. If you write base 10, then it's not wrong that way either. Okay, now let's see what we have next. Let's go from base 10 to another base. So we just did another base to base 10. So when you do that, you expand and multiply. If you go from base 10 to another base, you're going to divide. Okay. So it says determine the base 5 representation of 32. Whatever base they give you, your goal is to think about the positional values, maybe, in that base. So 5 to the 0 is 1. 5 to the first is 5. 5 squared is 25. 5 cubed is 125. Your goal is to find the highest power of 5 that will divide into 32. And in this case, the highest power of 5 that divides into 32 is this 5 squared. So I'm going to take 32, the number that they gave me, I'm going to divide it by 25. Now, once you find the highest power of the base that they give you that divides into that number, then you have to divide all of them all the way down to 1 to get your answer. Okay, so I'm going to start with 25 first, then I'm going to divide again by 5, and then again by 1 until I get all the way down to the lowest power. So 25 goes into 32 one time and leaves me with the 7 remainder. I take that remainder and I'm going to divide it by the next power of 5 down from 5 squared, which is 5 to the first. So I'm going to divide it by 5. 5 goes into 7 one time. That leaves me a 2. I'm going to take that remainder 2 and divide it by 1. 1 goes into 2 two times, which leaves me a remainder 0. So my goal is to eventually get down to 0. My numbers on top are my answer. Okay, so my answer is 1, 1, 2. Now I do need to write the base here because we're talking about base 5. Okay, so how could I check myself to see if I was right? Well, if you had 1, 1, 2 base 5, if you go and convert that to base 10 like we did just on the slide before, you could expand that out and see if it works. So it would be 1 times 5 squared plus 1 times 5 to the first plus 1 times 5 to the 0. And if you multiply that out, you get 32. And that's your check to be sure that you're right. But your answer is the 112 base 5. Okay, so there's base 5. Let's look at another one in a different base. Determine the base 6 representation of 216. Okay, so now we're talking about base 6. So I'm going to start with powers of 6. So 6 to the 0 is 1. 6 to the first is 6. 6 squared, 36. 6 cubed, 216. Now, I want the highest power, so I would keep going higher if I had a number bigger than 216. But since they gave me the value of 216, I've already found a value, the highest one that would divide into it. So I'm going to take 216. I'm going to divide it by the highest power of 6 that will divide into it, which in this case is our 6 cubed. So I'm going to divide it by 216. If I do that, 216 goes into 216 one time with a remainder of 0. Okay. Now, the trick that I said before is to find the highest power down, or the highest power that will divide into it, and then you have to work your way down until you get to 1, okay, to hold its positional value. So I'm going to take this remainder, and I've got to divide all the powers of 6 down to 1 by that. So I've divided by 216. The next one down is 36. 36 goes into 0 0 times, leaves me 0. Then I need to divide by 6. 6 goes into 0 0 times, leaves me 0. Then I've got to work my way all the way down until I get to 1. Okay, so my answer again is the numbers on top. So 1, 0, 0, 0, base 6. Now why do I have to divide all the powers until I get down to 1? Well, because I need this 1 right here to be in the 6 cubed position so that it has that value of 216. So if I check it, it's going to be 1 times 6 cubed plus 0 times 6 squared plus 0 times 6 to the first plus 0 times 6 to the 0, which gives me my 216, which is what I wanted. Okay, so if you know the different base and you want to get back to base 10, you expand it out. If they give you base 10 and they want the other base, then you have to divide it out. And whatever base they're asking for, that's the base that you're raising the powers to. Okay, so let's just summarize what we found quickly. Converting a number from a given base, so they give you a different base, to base 10. How are you going to do it? You're going to expand and multiply. Okay, expand it out, multiply it by the positional values, and then be sure that you're adding in the middle. If you're going a number from base 10 to another base, then that's when you're going to divide. So if you can keep those two things in mind, you should be able to keep it straight as far as what you're doing.